In this video, I'm going to show you how to graph quadratic equations that are in standard form. So standard form is our y equals ax squared plus bx plus c. This is the equation that I'm going to be graphing, y equals 2x squared minus 4x plus 10. So I'm going to follow the steps that I have here that we should eventually have memorized. And the first step is identify a, b, and c. So I'm just going to rewrite my standard form just above here. I have y equals ax squared plus bx plus c. Okay, so in identifying my a, b, and c, a is the number that's right in front of x squared. So here my a is 2. B is the number right in front of x. So here my b value is negative 4. So don't forget to include the sign with it. So here was a positive 2. We have positive 2. This will be negative 4 for b. And then lastly, c is that number that does not have an x with it, and we can see that is 10. Okay, so the next step is to find our axis of symmetry. So our formula for axis of symmetry is always going to be x equals negative b, or opposite b, over 2a. So I just figured out what a, b, and c are, and all I'm going to do is plug those values into the formula. So we can't forget it's negative b, so I have negative. My b value is negative 4. So I replaced b with the negative 4, but I kept the negative from the regular formula. So negative 4 over 2, and then my a value is 2. Another way we can think of this, it is opposite b over 2a. So talking about opposite, the opposite sign. So if our b is negative, the opposite sign will be a positive 4 over our 2a, which is 4. 4 over 4 comes out to be 1. So for my AOS, my axis of symmetry, x equals 1. Okay, so remember AOS, our axis of symmetry, this formula tells us where the halfway point is for our parabola. So what I'm going to do from here is go ahead and graph my x equals 1. So here's 1, and I'm going to draw a dashed line through 1 at the x value, just all the way down. Okay, so x equals 1. Now I just graphed x equals 1. Step 2, we just did step 2. Step 3, find the vertex by plugging in the AOS value. So if this is the center of our parabola, our vertex is going to be on this line somewhere. So to figure out where on the y-axis, we're going to have a point, well, where our y value is going to be for our x equals 1, we're going to plug 1 back into the original equation. So wherever I see x, I'm just going to replace it with 1. So I'll have y equals 2, replace x with 1, squared minus 4 times 1 plus 10. Okay, so you have two options. Mental math could work. You could always do mental math. Using Desmos, we just type it in as we see. So I'm just going to type in this expression here, including the parentheses. So don't forget those parentheses. So let's see, we have y, or not the y equals, we're just evaluating this. So we have 2 parentheses 1 squared, 2 parentheses 1 squared minus 4 parentheses 1 plus 10. So Desmos is not identifying parentheses here. Times 4 times 1 plus 10. There we go. I don't know why it didn't work before. So just typing in 2, and then just pretty much exactly how we have it here, replacing our x's with our axis of symmetry, which is 1. So this number is y equals, and we have 8. Right. So our axis of symmetry is the x value of our vertex. It's also the halfway point of our parabola. The y value is our y value of the vertex. So vertex, we have to always write as a point. Vertex is the highest or lowest point. So our highest or lowest point is going to be 1 from our axis of symmetry, comma 8 from plugging that into the equation. Vertex is 1, comma 8. Okay, next we need to find 2 points, and the easiest way to find 2 points with standard form is finding our y-intercept. So the y-intercept is always going to be 0, comma c, or thinking about our y-intercept, the ordered pair for any point on this axis is 0, comma something, and the c value is 10. So I'm going to do y-intercept is 0, comma our c value, which is 10. So this is this concept here is very similar to our slope point formula, y equals mx plus b. So that plus b is your y-intercept. That b term in the slope-intercept form does not have x with it either. So here, just 10, the number that doesn't have x with it, that's our y-intercept. So now I'm going to plot the points that I have so far. So the vertex, I have 1, 8. So this is 1, 1, 2, 3, 4, 5, 6, 7, 8. And then my y-intercept is 0, 10. So that's where it's going through the y-axis on here. Okay, so now I just want to find what my reflecting point is. So if I'm one space away from the center of my parabola, I'm going to go one space away to the other side, and I'll be right here. Okay, so for graphing, I want to label these points. So this point, we just said our vertex is 1, comma 8. This point is our y-intercept, or one of the other 2 points we need to find to graph a parabola. So this is 0, comma 10. And then this other point is going to be 2, comma 10. Okay, and then also labeling, this is my axis of symmetry, which is x equals 1. And then we can't leave it like this, we still need our parabola. So I'm just going to draw a parabola through this. It should be something like that. Okay, so the next thing I want to do is check my answer. So using Desmos, I'm going to type in what the answer should be. Or I'm going to type in my original equation. So this 2x squared, so 2 takes a little longer on the iPad, but x squared minus 4x and plus 10. Okay, so looking at this graph and looking at the one that I have, okay, adding a 0 would be good too, so plus 10. Okay, so it looks about the same, right? But we don't want to just go on looks, we want to confirm. So the nice thing with Desmos is the points that come up, the points that automatically come up on Desmos will be your vertex as one of them. So when you click on it, I see the vertex should be 1, comma 8. That's what I have. And then the y-intercept should be 0, comma 10. That's what I have. We can also type in our axis of symmetry, which is x equals 1. And I just want to change that line to dashed, just so it's accurate. So that's what our graph should look like, and we checked our points using Desmos to confirm that it is 1, comma 8 and 0, comma 10. So what happens is if the point on your vertex is different from what you have figured out in your equations here, you want to go back and just double check your work. Make sure you have negative b over 2a for your x value, and make sure that you're plugging it in properly back into the equation. Okay, so I want to do one more problem with standard form. And that's when we have a missing value. So going through our steps again. Okay, so again, I'm just going to write the standard form. Actually, no, I have it written here. So let's see. So looking at our standard form just above it, the first step is identify our a, b, and c. So the number with x squared is going to be our a. So we have x squared. So when we're missing a number in front of x, that means there's an invisible one. So in this case, it's going to be an invisible -1 because it's negative x. B is the number that should be with x, and we see, well, there's no just x value. So since just x is missing, we would put 0 in for B. And then C is our number without x with it. So here we have C equals 6. Okay, next step, finding our axis of symmetry. So remember, that's this formula, -b over 2a. X equals -b over 2a. Just back on. Right, so -b, and b is 0. So let's just plug the values we have for the letters in. This would look like -0 over 2 times -1. And if you have 0 in the numerator, this fraction will just equal 0. Okay, if you have 0 in the denominator, then it's undefined, and should double check what our values are then. So here our axis of symmetry will be x equals 0. Okay, so looking at our graph, x equals 0 is going to be our 0 value is the y-axis. So I'm just going to do a dashed line over the y-axis because that's our axis of symmetry. Okay, next we have plugging in our vertex of 0, so I'm sorry, our axis of symmetry, which is 0, back into the original equation. So I'm going to have y equals -0 squared plus 6. Okay, so I just replaced x with 0. So the thing with this equation is it's fairly easy to solve from here. 0 squared is 0, it's -0. This is just all going to be 0 plus 6. So my y value is 6. Therefore, my axis of symmetry is 0. My vertex is the x value for my axis of symmetry, which is 0, and the y value from when I plugged it back into the original, so 0, 6. Okay, so vertex again is our highest or lowest point. So I have 0, 6, so 0, 6. So this is a special case because 0, 6 is on our y-axis. So what happens, how do we find two other points if our y-intercept is the vertex? Okay, so this is what we do when this is the same, the y-intercept is the same as our vertex. I'm just going to make a little table of values. I'm going to put my vertex in the middle, 0, 6. And I'm going to choose, going up from 0, I'm going to go up to 2. Okay, so 0, 1, 2. And then the symmetrical side from 2 would be -1, -2. Okay, so this is just choosing two random points. So I'm choosing 2 to plug in. So I chose a number that's going to be to the right of my axis of symmetry. I could have chosen 1, but I'd like to choose 2 just to see how far out it will go or how narrow it will be. If I just chose 1, it'll be such a short distance to see that change. So I chose 2, and then I'm going to plug 2 back into the original equation. So I have -2 squared plus 6. Okay, so again, we can use Desmos to help us calculate this. Notice the negative sign is on the outside of our parentheses, right? 2 isn't negative that we're putting in for x, but it's negative on the outside of x. So that should look the same as how you type it into Desmos. So I have negative, and I'm plugging in 2 squared plus 6. Okay, and that comes out to be 2. Right, 2 squared is 4. Keeping that negative, we have positive 2. So this will be 2, 2. Okay, and I'm going to plot that point, 2, 2. So I have 2, and I'm going to go up 2. Right. There's a couple ways we can use a table of value to help us find these reflecting points, or we could do it by graphing. So finding the other side, the reflection of this point, I am 2 to the right of my axis of symmetry, so I'm going to go 2 to the left to find that other point. Okay, so this one will be negative 2, 2, so negative 2, 2. So notice, like, when we look at this on a table of values, if you go the same distance from 0 up as you do down, so we went 2 up and 2 down, then these y values are going to be the same. So you can use a table of values or using the graph to figure that out. Okay, and all that's left is drawing our parabola through. So should look something like this. And now checking our answers. So you should definitely use pencil when you do these. I'm using pen so you can see it on the video. Let's check these answers. So we have negative x squared plus 6. Okay. And looking at that and looking at what we have, so my vertex is 0, 6, and that's what we have here, labeling our graph 0, 6 for the vertex. Let's check the points that we chose here. So I chose 2, 2. So I'm going to type in those points into here, 2, 2. And we see it lands on the graph. And how about the other point of negative 2, 2? So we have negative 2, 2. Okay, so both of our points show up on the graph, so that confirms what we have here. So just labeling the graph, we have 2, 2, and then negative 2, 2. This is our vertex, and this is our AOS of x equals 0. Okay, so I hope these videos will help you. You can pause it as you go to go over it again and check your work, but use Desmos as this tool. If your points are not matching up with Desmos, then go back into your work and try to figure out where you went wrong to see how you would get the values that you see on Desmos.